Welcome, dear children. Standard 7, Subject Science. We are going to start with our new lesson, lesson number 7, Motion, Force and Work. Can you see the picture above? What you can infer from the above picture? You can see a man riding a cycle, a boy running, and a girl is playing with a football. From this image, we can say that the work is said to be done. There is a motion. Now, can you tell me what is a motion? Motion means displacement or a change in the position of an object over a time. When an object changes its position with elapse of time in respect to a stationary object. We can define motion as the change of position of an object with respect to time. A book falling off a table, water flowing from the tap, rattling windows, etc. all exhibit motion. Even the air that we breathe exhibit motion. Everything in the universe moves. We live in a universe that is in a continual motion. The fundamental particle of a matter, that is the atom, is in a constant motion too. Every physical process in the universe is composed of a motion of some sort. The motion can be either be swift or slow, but motion exists. It is important that we give due attention to the study of motion because of its importance in the physical world. Motion is mainly described in the term of following terms: distance, displacement, speed and time. For example, if an object A cover a distance in less time and another object cover the same distance in more time, the object A is called a faster moving object and object B is called a slower moving object. In other words, object A has a faster motion and object B has a slower motion. So, motion means displacement of an object from one place to another. For example, pushing a block, opening a door, etc. are all the different types of motion. A change occurs in the motion or the shape of the body when a force acts on it. Motion is caused by force. A stationary object does not move unless a force acts on it to start it going. We might have noticed that different objects move differently. Some objects move in a curved path, some in a straight path and few other in a different way. According to the nature of movement, motion is classified. As we had studied in our previous standard, there are different types of motion: oscillatory motion, random motion, linear motion and circular motion. So, we are going to study in detail about motion, work and force. So, we are going to study topic distance and displacement, speed, velocity, average velocity and instantaneous velocity. Let us study distance and displacement with the help of an activity. You can see, children, in the figure there is a 4-point A, B, C and D. So, A is the point where Ranjit house and D is the point where Ranjit's school is there. Now, Ranjit wants to go from his house to his school. So, what he does, he uses the route which is 500 meter and travel that in 8 minutes. Then B 700 meter traveled in 11 minutes. And the final distance is CD, that is 300 meter in 6 minutes. Now, what happened? Ranjit traveling from home to school. So, AB plus BC plus CD. This is the distance travelled by Ranjit, right, irrespective of the direction. You can see the dotted line over here. That is the minimum distance travelled from Ranjit from A to D, from house to school. So, the minimum distance travelled in a straight line in one direction. So, that is called as a displacement. So, AB, BC, CD is the distance travelled and AD is the displacement because it is the minimum distance travelled in one particular direction from one original point to the end point. Original point is A and the end point is D. Are used to describe the change in position. Now if someone asks what is the distance between A and B, we cannot give a definite answer because it depends on the path taken. It may or may not be the same for all the three paths. But for displacement, we can always give a definite answer as it is straight line joining the 2 points. In the other word, displacement is nothing but the shortest distance between the 2 points, which in the case is path 2. Also, it has been a particular direction for A to B as we can see. So, distance, the length of the route actually traversed by a moving body irrespective of the direction is called distance. Distance is a scalar quantity. The distance of an object can be defined as the complete path traveled by an object. Example, if a car travels east for 5 km and take a turns to travel north for another 8 km, the total distance traveled by a car shall be 13 km. The minimum distance traversed by a moving body in one direction from the original point to reach the final point is called displacement. Unit of measurement of distance and displacement is the meter in SI. SI is Standard International and MKS system. Displacement is a vector quantity. Now here in the figure you can see A to F through A to B to CD. E and F is the distance travelled by blue car is the distance travelled. AF is the displacement of a brown car. Distance and displacement. Another example for displacement and distance. Two cars start out at exactly the same location. Blue car 500 meter west of the starting point. Red car 500 meter east of the starting point. After a given amount of time, each car has travelled 500 meters. The distance that they have travelled is the same. However, since they have travelled in a different direction, their displacement are different. Distance is a scalar quantity where displacement is a vector quantity. Displacement is a vector quantity and not a scalar quantity because it can only describe by using both magnitude as well as a direction. Distance on the other hand is a scalar quantity since we need to know only about the path taken. In comparison, the path does not matter in the case of displacement. Displacement is defined as a changes in the position of an object. It is a vector quantity and has a direction and magnitude. It represented as an arrow that points from the starting position to the final position. For example, if an object moves from A position to B, then the object's position changes. Here the dotted line you can see is the distance and the straight line which is seen is the displacement. Speed. The distance traversed by an object in a unit time is called the speed of that object. Speed formula is distance traversed upon time required. It's a scalar quantity. Speed is a way of measuring how quickly something is moving or being done or something move fast. The speed of a car is 40 km per hour. There is no need to specify the direction. But to predict whether a storm will reach a particular place or not, a mention of its direction is essential. Speed can be thought of as the rate at which an object covers distance. A fast-moving object has a high speed and covers a relatively large distance in a short amount of time. Velocity. Velocity is the distance traversed by a body in a specific direction in a unit time. The velocity of a body can be calculated by the following formula. Velocity is equal to displacement upon period of time required for the displacement. Example, a train moves at a high velocity. Velocity is the rate of motion, speed or action. An example of velocity is a car driving at 75 miles per hour. Someone who takes 40 minutes to drive 20 miles north and 20 miles south to end up at the same place has an average speed of 40 miles divided by 40 minutes or 1 miles per minute. So, Average velocity, however, involves total displacement instead of distance. Speed and velocity. Speed, distance traveled per unit time, is called speed. Velocity is the rate of change of the object position with respect to time. Speed is equal to distance traveled upon time. Velocity is equal to displacement time required for the displacement. Unit of speed and velocity is meter per second. Speed, being a scalar quantity, is the rate at which an object covers distance. The average speed is the distance per time ratio. On the other hand, velocity is a vector quantity. It is a direction aware. Velocity is the rate at which the position changes. When no force of friction is acting on a moving body, it will keep on moving with a constant velocity. Quantity, formula, unit of quantities and unit of final quantity. Speed, distance upon time required. Unit of quantity is meter per second. Velocity, displacement upon time required for displacement. Unit of quantity is meter per second. Average velocity and instantaneous velocity. The velocity of an object can change even while it is moving along a straight line. Suppose that a truck is covering a distance of 40 km from A to D in a straight line. That is, its displacement will be 40 km. If it requires altogether 1 hour for this, its average velocity is 40 km per hour. However, if the truck travels the 10 km distance AB in 10 BC in 20 minutes and CD in 30 minutes, then the velocity for the distance AB in km per hour is 10 km upon 10 minutes. That is 60 km upon 60 minutes. That will be 60 km per hour. Similarly, the velocity for the distance BC 30 km and CD 40 km, we see that the truck is different in the different segment of the road AB, BC and CD. However, the average velocity for the entire route AD is 40 km per hour. The velocity at a particular moment of time is called instantaneous velocity. The instantaneous velocity can be different at a different time. The velocity at a particular moment of time is called instantaneous velocity. It changes with the change in time. So, let's recall what we have studied. We had studied about motion, distance and displacement, speed and velocity, and average velocity and instantaneous velocity. In our next video, we are going to study about acceleration, Newton's first law of motion, force, displacement and work. Thank you.